Here we have a SAT math problem. Okay, let's go to the question. If the square of a is equal to the cube of b, where a is greater than or equal to 0 and b is greater than or equal to 0, for what value of x is square root of a to the power of x equal to b? That is, square root of a to the power of x is equal to b. So when this one is equal to b, we have to solve for x. That is, we have to solve for x in this equation. Okay, in my first step, let me write the square root as an exponent. When I write the square root as an exponent, the exponent will be 1 half. On the right side, we can write this b as it is. Okay, here a power is raised to another power. Whenever a power is raised to another power, we can multiply the two exponents over here using the power of a power rule. Then we get a to the power of, when I multiply x and 1 over 2, I have to multiply this x and the numerator 1. That is, I am getting x over 2 equals to b. Okay, here I am trying to solve for the variable that is at the exponent. Whenever I want to solve for a quantity that is at the exponent, I need the same base on both sides of the equation. Here on the left side we have the base a, on the right side we have base b. That is, we can consider this b as b to the first part, then we have base b. So the base on the left side and the base on the right side are not same. So our aim is to get the same base on both sides of this equation. Once we get the same base, we can equate the exponents and we can solve for x. For that, we have to consider this particular piece of information, that is a square of a is equal to the cube of b. So that is square of a square equals to cube of b, that is b to the third power. Okay, here what we have to do is we have to solve for b in this equation. Once we get the stuff for b, we can plug in for b over here. Okay, to solve for b, we have to get rid of this exponent 3. How do we have to get rid of the exponent 3? For that, we have to raise both sides of this equation to the power of 1/3. Okay, let me do it. That is a square is raised to the power of 1/3, and also on the right side this b to the third power is raised to the power of 1/3. Okay, here your power is raised to another power. Now we can multiply the two exponents using the power of a power rule. Then we have to multiply this 2 and the numerator 1. 2 times 1 is 2, that is we get 2 over 3. And here the same thing, when I multiply the two exponents 3 and 1 over 3, I am getting 3 over 3. So then we get a to the power of 2 over 3 equals to b to the power of 3 over 3 is 1, that is b to the first power. B to the first power is just b. Okay, here I got the stuff that is equal to b, that is a to the power of 2 over 3 equals to b. Now we can plug in this a to the power of 2 over 3 for b over here. Okay, now let me do it. That is a to the power of x over 2 equals to a to the power of 2 over 3. Okay, now two powers are equal with the same base. That is, the base on the left side is a, the base on the right side is also a. So whenever two powers are equal with the same base, we can equate the exponents. Okay, now let me equate the exponents. Then I am getting x over 2 equals to 2 over 3. Okay, now to get rid of the denominator 2 over here, we have to multiply both sides of the equation by 2. Let me do it. Then this 2 will cancel out. Then we get x on the left side. On the right side, 2 times 2 is 4. That is, we get 4 over 3. Okay, here I got the value of x, that is 4 over 3. When x equals to 4 over 3, square root of a to the power of x is equal to b.